All right, everybody, this is your captain speaking. We're getting ready to fly into a journey into the unknown, known as Precalculus Second 6 Weeks Test Review. So please take a few notes. You're allowed to use them in your journal, or you don't. You can just not use them either way. Now, this number one, it says find the what? Find the inverse. So if you would please, just simply put f of x in your journal. Put f of x equals, but make a better equal sign, because that was horrible. 1/4 x minus 7. Now, whenever you're finding the inverse, make sure that after you put y equals, this is where I'm going to ask my class if they remember what to do next. What should we do? Exactly. You switch the x and the y. So there we go. Ready? Switch the x and the y. And after you switch the x and the y, now you need to do one thing and one thing only. I need you to solve for y. So you're solving for the value of y. All right, so what do we need to do to solve for y? Here's a hint. So we got to get this to 0. So what do I got to do? I got to add 7 to this side and add 7 to this side. Now, these aren't like terms. So this becomes x plus 7 equals 1/4 of y. There we go. That's step number something. I don't know. Step number something. Now, once we get all the y's by themselves, then somebody said, hey, we need to multiply everything by a 4. Okay? And that's basically what you're going to have to do. You're going to have to multiply this side by a 4, and you're going to have to multiply this whole enchilada right here by a 4. Technically, yes, it's a binomial, x plus 7. I just like to have fun. So here we go. So this 4 cancels out this 1/4. All right? And so what do we have left? We have a y equals 4 parentheses x plus 7. Is this technically the inverse? It is, right? It's technically the inverse. However, if we simplify it or expand it, what could we also write the inverse as? 4x plus 28. So the final answer, everybody, the final answer that was this particular question, the inverse of our original function, which was f of x, so the inverse of that function is 4x plus 28. That's the inverse. So on the 6 weeks test, there will be a linear function, at least one, that you actually have to find an inverse of. Okay? Now, what would be another correct expression that you might see that would still be acceptable? That would be it could leave it as 4 parentheses x plus. So these are technically the same. All right? This has just been distributed. This has not been distributed. All right? So on this one, if we look up here, I don't know if you could see it. What would be the answer choice on this particular answer? I think would be answer choice D. All right? Okay, so here's a clue, guys. Here's a clue. All right? If you see 1/4, you know the inverse is going to be 4/1. So that's another way of looking at it. This one's a little bit different, okay? Let me explain to you why I had to restrict the domain to this. So could you guys please, right now, what I need you guys to write in your journal is I need you guys to write this down, and it's going to be important that you restrict the domain to x's greater than or equal to 0, because I'm also going to use this as an opportunity to switch the domain to x is less than or equal to 0. I want to make sure you guys know the understanding of the difference between the two. So right now, number 2, I need you guys to write this down, and we're going to solve it, and I'm going to show you in Desmos why the restricted domain is important. So we're going to start with this. And it's important that you restrict the domain to x is greater than or equal to 0. So step 1. I'm going to go ahead and pause. All right, so step number 1. What are we doing, everybody? Yep, flipping the old, swapping the old, whatever you want to call it, the y and the x. Here we go. Step number 2. After we do that, what are we going to add to both sides? Add 5. There we go. Add a 5. That zeroes out. Add a 5 to this side. Can we combine those? No, can't combine them. Okay? So here's what we have left. We have y squared equals x plus 5. So if I want to go from y squared, and I just want to know what y equals, what do we have to do? Yeah. So the only way to unsquare something that's being squared is to take what's called the square root. Okay? And so we have to take the square root of x plus 5. So the inverse, okay? The inverse of this is the square root of x plus 5. Okay? That's if the domain was restricted to what? X is greater than or equal to 0. So right now, this is if the original domain was what? X is greater than or equal to 0. So let me show you guys what I mean by that. Okay? All right, so let me go to Desmos real quick. All right, I'm going to go to Desmos. Keep it up here. All right, so our original function, what was our original function? Y equaled, was it x squared plus 5? X squared minus 5? Like that? Okay. Now, if I wanted to restrict the domain, remember I said the domain had to be restricted to what? X is greater than or equal to 0, so I got to put that little, there's a little bracket, a little set bracket. I got to put x has to be greater than or equal to 0. Do you see what it does to the graph? It restricts the domain right here. Now, what did we say our final answer was? Y equals the square root of x, x, was x plus 5? Okay. Now, I don't know if you guys can see this, but these, remember, inverses always reflect over a certain line. Does anybody remember what that certain line is that inverses always reflect across? Y equals x. Do you see that? Now, let me explain something. This is where I need you guys to write something down in your journal. If I change this from greater than or equal to, okay, and I make it x is less than or equal to, can you see how these are no longer inverses of each other? What did I have to change if I made it less than or equal to? What did I have to change right there? I had to put a negative. So I'm going to take a screenshot of this real quick. Ready? I'm taking a screenshot of that. Then I'm going to go back to where it was. Take a screenshot of this. What do you notice about the inverses between this and this? Can everybody see the difference, how those are indeed inverses? Yeah. So listen, what I want you guys to understand is if, all right, this is the tough part. If I change that, ready? If I change that to it's x is less than or equal to, then what would my inverse be? My inverse would be a negative square root of x plus 5. If it was x is less than or equal to 0. So this is what I'd like you to put into your journal. Now, technically, I want you guys to understand this right here. Technically, when I take the square root of something being squared on both sides, technically it's plus or minus the square root of x plus 5. The positive version one is where x is greater than or equal to 0. The negative version is when x is less than or equal to 0. Because one thing we can't have when we have a parabola is we can't have an inverse that is actually a function. All right? So you're like, what are you talking about here? So let me show you. Ready? Okay. So if we have this, and I switch out the x and the y's, okay? Does everybody understand that these are inverses of each other? But the only problem is the blue actually a function? No, because it doesn't pass the vertical line test. Do you guys remember when I said that if this passes the horizontal line test, then its inverse would be a function? Well, this does not pass the horizontal line test that we talked about before. All right, so that's something you got to be wary of, or you have to make sure you're paying attention to. Okay. All right, so right now, what I'd like you to do is I'd like you guys to go ahead and put number 3 carefully into your journal. The reason we're going to do number 3, now we're not going to probably do every single one of these problems, okay? But the reason we're going to do number 3 is because you're dealing with a fraction. I want to make sure you guys know what to do when you're dealing with a fraction. So go ahead and put that one down carefully, nice and neat into your journal. I'll write it down as well. So we have g of x equals negative 5 over 2 x plus 3. I'm trying to write down nice and neat as best as I can. So once again, we're going to swap the old x and the y. Okay, there we go. All right, first step, y'all. First step. What are we going to do to both sides? Very good. We got to subtract 3 right here from this side and subtract 3 from this side. So we can't combine those, can we? No, that'd be bad. All right. I see it happen in my Algebra 1 class all the time. It's like they just try to combine something that's not alike. So what are we left with? We're left with what? Negative 5 over 2y. And what is that? What is negative 5 over 2y equal to? X minus 3. All right. So listen. One thing you need to understand is here's what students like to do. They see negative 5 over 2, and they want to try to divide everything by what? Negative 5 over 2. Do not do this. Do not do what I'm writing here. Do not do that. That's just way too much work. This looks ridiculous when it comes to trying to do it in your head. So we're going to go back. So whenever you get a fraction, do not divide by that fraction. What I want you to do is I want you to multiply both sides by the reciprocal. Well, what is the reciprocal of a negative 5 over 2? Close. Negative 2 over 5. So we're going to multiply both sides by what's called negative 2 over 5. If I would have had more room, I'd put it right there. Okay? Now, here's what happens. That negative 2/5 multiplied by that negative 5 over 2 cancels out, and you're simply left with y equals. Now, we're going to go ahead and distribute this sucker. All right? So negative 2/5 times x is negative 2/5 of x. And a negative times a negative is a positive. And 3 times 2 is 6 over 5. So that is my final answer. Now, here is another acceptable, albeit not simplified answer. Negative 2 over 5 times x minus 3 would be considered an acceptable or equivalent answer if it was in multiple choice. Or, I know. Does anybody want to give me something else that it could be? I'll go and pause and see if anybody comes up with another acceptable answer. All right, so check this out. We're going to go right over here. This is being multiplied by a negative 2. I'm going to open up a parentheses. I'm going to put x minus 3 all over a 5. That's another way of looking at it. Now, another student said that was a positive 2 and that's a negative 5. That would still work. Okay? But I'm going to say the best answer is going to be the inverse of our original function is negative 2/5 of x plus 6 over 5. Now, I don't know which one you're going to have on your 6 weeks test, but I'm going to say I want to make sure you guys understand you got to be able to find. Now, this one was, I think, worked all the way out. So this is going to be answer choice D in this particular question. Okay? All right, number 4. Okay, everybody. What I want you guys to do right now is I need you guys to write this, because we're going to do this, but we're also going to do f of g of x for the same question. All right, so do g of f of x equals, make sure you guys understand f of x is x minus 1 and g of x is x squared. So the first thing we're going to do is we're actually going to do what's called g of f of x. So this right here is a review of what's called a composition of functions. We're doing a composition of functions. All right, so what does g of f of x mean? It means we're taking f of x, and what are we literally plugging it into? Taking that, we're plugging it into g of x. All right, so here we go. What does that equal to? So we have I'm gonna open up a parentheses, all right? Because what we're gonna do is we're gonna take this guy right here. We're taking x minus 1, and I'm plugging it in right there. So I'm gonna take f of x, which is x minus 1, and what am I gonna do to it? I'm going to square it. And that's your answer. You're like, wait a second, I don't see that answer. Well, what does that mean? It means x minus 1 times x minus 1. Anybody remember what that's called? When you have x minus 1 times x minus 1? It has like a vocabulary. Nobody? Nobody? Yeah, sum of squares. That's right. It's the sum of squares. Okay? So we got x squared. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 1 is positive 1. And there's your answer. Okay? So this answer happened to be answer choice B. Wait a second. What if I went the other way? What is f of g of x? Where I'm taking g of x, and then what am I doing? I'm plugging it into f of x. Well, that's easy. That says what? X minus 1. So literally, what am I plugging in right there? I'm just plugging in an x squared. So this would be x squared minus 1. Anybody see that answer anywhere? That'd be answer choice A. So if I could actually use this exact same question to do what? Just switch out the G and the F and change it from answer choice B to answer choice A. So f of g of x is x squared minus 1. G of f of x is x squared minus 2x plus 1. All right. Hopefully I didn't go over that too fast. Whew. Holy moly. Okay. Well, we got one more of these, and then we get to do some more fun stuff, which is we got to do some synthetic division. Okay? All right. So here we go. One more, and we're going to call that done for the composition of functions right here. All right. So one more. I'll give you a chance to jot it down. We've got this right here. So I'm going to put f of x in blue. And I will put g of x in red. And it looks like we're doing f of g of x. Oh, that was so nice. All right, here we go. We're doing f of g of x. Which means I'm going to take g of x, which is this guy right here. All right? Taking him. And what am I throwing him into? I'm throwing him into f of x. So right here, I'm just taking that guy and I'm going right over here, and I'm literally just plugging it in right there for the x. So I put 4. I open up a big old fat parentheses and put minus 2. All right. What am I plugging in? 2x squared plus 3. All right. So when I do that, now I just got to do what? 4 times 2, which is 8. 4 times 3, which is 12. And then we have a what? Minus 2. And you get 8x squared plus 10. And that's your answer. What would be the harder one? Yeah, the opposite would be the harder one. Okay? G of f of x. If we did G, now I'm not going to work all this one all the way out, okay? G of f of x, if you wanted to find G of f of x, now I would have to put a 2. I'd open up a big old parentheses, I would square it, then I would put plus 3, and I'd have to do 4x minus 2. All right, and so you'd have to multiply that to itself. It doesn't take a whole lot of time, but eventually you end up getting this guy. All right. All right, as we keep moving forward, right now, I don't know if you guys can see number 6, but right now we have this right here. What do I refer that as? You could call that the chair, you could call it the box, however you want to do it. We have a nice long line, and we have 1, 2, 3. Yeah, I'm going to make it bigger, okay? So right here, this says x to the power of 4. All right, so I'm going to make this. Ready? X to the power of 4 minus 3x cubed minus 15x squared plus 19x plus 30. And that big, huge, long polynomial is being divided by what number? Sorry, what binomial? X minus 5. So that's problem number 6. So in your journal, I want to make sure you guys understand synthetic division. We're going to start with, not x to the power of 5. My apologies. Going to go with x to the power of 4, then x cubed, then x squared, then x to the first, then x to the 0. So how many x to the power of 4s do I have? 1. How many x cubes do I have? Negative 3. How many x squareds? There we go, negative 15. X to the firsts, 19, and then we have 30 right there. This is where students will mess up. If I said, hey, what number would I put in right there? I put a positive 5. So if this is the factor, it's always going to be the opposite. Like, what number would you plug in there to make it equal to 0? Okay? So this one, you didn't even have to solve it. You said to do what? Just set it up. Okay? So what should it fill? So by the way, I've made a template. Okay? I've made a template so I can just kind of go in and I can change things out. So just make sure you know like what numbers you'd have to plug in. Okay? Somebody actually gave me a heart. They said they liked my synthetic division quiz. I was like, oh, thanks. All right, okay, here we go, guys. Let's go ahead and practice number 7. All right? Here we go. Number 7. I'm going to give you a chance right now. Just write it down. Just do that. Okay? After you write that down, we're going to go ahead and set it up nice and neat. No, the whole test is not going to be over synthetic division. All right? I know. It'd be like, sweet, going to get a super good A on that. All right? So if you would, put y cubed. I'm sorry? Hey, be nice. Okay, there we go. All right, everybody. You got now. This is kind of like how I like to set it up. This is kind of the way the textbook sets it up. Okay, so I like doing it this way. All right. How many y cubes do I have? 1. Y squareds? Y to the first. There's nothing there. So make sure when you're doing it, if you don't see like a y to the power of 1, make sure you fill in that spot with a 0. And then put what? Negative 10. Now if that says y plus 3, what are we putting over here, everybody? Boom, negative 3. Put it in. Okay, could anybody in my class give me instructions right now of what I'm going to draw next? Take the 1 down. I like it. Good. What do I do with the negative 3 and the 1? Multiply. What you got? Negative 3. Okay, what do I got to do with these guys? Add. So I got to put plus. Add them together for me. Good. Ooh. What are we doing with those? Multiply. Okay, what do you got? Boom. Got it. All right, we got 6 here. What do we do with those? Multiply. Good. Add them together. We get what? Ha-ha. Now, what does it say? What is the what? What is the? Boom. There's the remainder. Now, does anybody remember what's called the remainder factor theorem? The remainder factor, that's supposed to be an E. Okay, the remainder factor theorem. Now, guys, the remainder factor theorem states that if the remainder is equal to 0, then this binomial would be a factor. So we would say this is not a factor because its remainder is not 0. The only time you know it's a factor is if this number right here, the remainder is 0. So that's the remainder factor theorem. So in case you get a question about it, like what would the remainder have to be in order for it to be a factor? You would say? I'm just waiting. Yes, it would need to be 0. Thank you. That's all it needs to be. It just needs to be 0 right there. That's it. That's all I got to do. Okay, we're not going to do number 8. Okay. Ooh, Pascal's triangle. All right. Okay, let's take a look at this. All right. Only one of these is correct. Which one would you guys say is the correct? Yes. So could you guys please just make that in your journal, and we're going to continue it. All right, just for a few more rows. We're just going to continue it, okay? I'm going to give you a chance to build it. Yes, do the C. C's the correct one. Don't do any, just this one right here. I'm going to add a little extra line here. What am I going to put here after the one between the 1 and the 5? I'm going to put a 6. Add them together. Put a 15. I'm going to put a 20. Then 15. Then 6. Then 1. Okay. Now, when you're doing it, I need you guys to label some things. Ready? I want you to label this. This is called row 0. This is row 1. Row 2. And I'm going to put row 3, and then I'll just kind of put like a down arrow. Like from there, you should be able to figure out the row. Now, it's very, 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 very easy to figure out what row you're in if you just look at these numbers. Ah, yes. All right, if you guys would, please. All right, if you guys would, I want to see if you guys can go to your graphing calculators. Can you guys go to your graphing calculators real quick? Okay, I want to show you guys something here, okay? So check this out. If you guys go to math and you go to where it says probability and you go down to number 3. I'll do it one more time, okay? You go to math, you go over to where it says probability and you go down to number 3, okay? This is permutations and combinations. So C represents combinations. We haven't talked about it yet, but check this out. If I said 6 and I put a 0, you get 1, okay? If I put 6, choose 1, you get 6. If I go up here and I put 6, choose 2, you get 15. If I put 6, choose 3, you get 20. 6C. Yes. Okay, now what I'm doing right now is I'm trying to show you guys a cool little pattern here. Does everybody see what I'm doing there? 1, 6, 15, 20. So listen, I want you guys to see something real quick, okay? Right here, we can figure out, using, without even the Pascal's triangle, this is saying this is what? Row number 6, okay? So we have, and we can figure out which element we're going to be having right here, all right? So if I wanted to say we have 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, right? 6, 7. There are how many elements right there in that? There are 7 elements. They go from what? 0 all the way over to 7, okay? So if I said, go back over to, you can kind of see how you finish the, oop, I went the wrong way. I apologize. I meant to do 6C5. And then eventually, there we go. Okay? So, this is your Pascal's triangle, all right? So, if we're working on this, if we wanted to do a binomial expansion of x plus 1, this is going to be our last problem that we do for today. So what I'd like you to do right now is I'd like you guys to do binomial expansion of x plus 1, but what row are we working with? We're working with row number 5, which basically means we're doing this row right in here, okay? Okay, so what we're going to do is you guys can pretty much clearly see what the answer is going to be without really doing any work on this one, okay? What would be, which answer would you guys choose without having to really do any work, just knowing that this says to the power of 5, and we're dealing with a 1, a 5, a 10, a 10, a 5, and a 1, right? We know it's going to be what? A, okay? Now, we're going to do something a little bit harder here, all right? I want you guys to do 2x minus 3 to the power of 5. So we're going to do 2x minus 3 to the power of 5, and that's the one that I want you guys to do in your journal, okay? So go ahead, write this one down. I'm going to show you guys how to set it up, and this, we're just going to do this. This will be the last problem that we do today. Okay, when you guys are setting it up, it's very important that you put this one in front, and you put the negative 3 in the back. All right, so go ahead and do that. So right here, put a 2x, 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 2x. And in the back, you're going to put minus 3, minus 3, minus 3, all the way down the line. If you start with the power of 5, then you have to go 5, then 4, then 3, then 2, then 1, then 0. Conversely, you start with 0 and then go 1, and 2, and 3, and 4, and 5. And that's how you guys have to set it up. All right? So, right now, I want to make sure you guys know how to set it up. We will finish this tomorrow, and we'll finish up doing the review, and then you guys will have how many days to take your 6 weeks test? 2.